Good morning, good afternoon, good evening. Guys, let's start. Once again, we'll be doing with the VPN topic, and this time I'm taking Flex VPN as a topic. Let me share my screen. So on my screen, you can see there's a slide. Okay. What is your Flex VPN? Okay. We already finished site-to-site VPN between two routers. Okay. So when I explained you about IPsec VPN, I told you that in IPsec you have sub-protocols. IPsec is having sub-protocols, and those sub-protocols are ISA-KMP, ESP, and AH. But when I say ISA-KMP, the synonymous word for this was IKE v2. Sorry, IKE. But when I say ISA-KMP, that means it takes version 1. But later on they said no, we'll also have version 2, comparison with version 1. And there were a lot of difference or lot of good things they added in version 2. So version 1 is the older version, or you can say legacy, and version 2 is the new one. So first we'll see what is the difference between version 1 and version 2. Okay. So if I consider IKE version 1 versus IKE version 2, you can see on the slide, which stands for Internet Key Exchange. ISA-KMP is a big name, Internet Security Association Key Management Protocol. The synonymous for ISA-KMP was Internet Key Exchange. And that time it was only version 1. Okay. So Internet Key Exchange is a protocol that belongs to IPsec protocol suite. I told you IPsec is a suite of protocol which carries ISA-KMP, ESP, that is encapsulating security payload, and AH, authentication header. So IKE, which is also part of IKE, is nothing but ISA-KMP only. Its responsibility is in setting up security association between two parties or between two peers. Okay. IKE was introduced in 1998 and was later superseded by version 2. That just now I told you. So there are a number of differences between IKE version 1 and IKE version 2. Okay. One is reduced bandwidth requirement. See, IPsec is heavy in process. The process consumption, the memory consumption is too high. So when you do VPN on any device, either whether it is a router, whether it is a firewall, it is going to consume the hardware, it is going to consume the memory, it is going to consume your process, your memory, your bandwidth. So they said in IKE version 2, the bandwidth requirement is less, reduced. Okay. And see, if the bandwidth requirement is less, what will happen? You will be giving more bandwidth to other traffic. Otherwise, what will happen? IPsec or IKE v1 itself is going to acquire all the bandwidth. So at least IKE v2 is good by not taking that much bandwidth. So the bandwidth requirement of IKE v2 is very less. So you can use the remaining bandwidth for transmission of the data. Another second difference is the inclusion of EAP authentication. IKE was not having EAP. EAP means nothing but extensible authentication protocol. Okay. So EAP authentication, which is again a very good protocol. So they said, okay, so we'll be using EAP authentication, okay, which was not there in IKE version 1. IKE version 2 also supports mobile, while IKE version 1 doesn't. Okay, mobile devices support is there with IKE version 1. Okay. Fourth, IKE version 2 has built-in NAT traversal while IKE version 1 doesn't. Now you know that in IKE version 1, if we consider tunnel mode, it encapsulates everything like source IP, destination IP, source port, destination port, everything. So if we are doing NAT, what happens? You have to add an additional port, UDP port, okay, to make this possible. So NAT traversal was the feature we used to do in IKE version 1. Okay. Extra. You have to do extra something. IKE version 2 is having built-in NAT traversal, while IKE version doesn't have that. So IKE version 2 can detect whether a tunnel is, that means dead pair detection kind of stuff. Continuously, there will be some kind of activity going on to detect whether the tunnel is still alive. That is not possible in IKE version 1. Okay. So in short, if I write down the summary, this is the difference you will find in IKE version 2. Okay. So first we will see how this Flex VPN works. So definitely Flex VPN is the name for IKE v2. Normally we have done site-to-site VPN, we have done remote VPN, hub and spoke, spoke to spoke, full mesh. All this can be done with Flex VPN also. Okay. Flex VPN architecture, modular configuration, modern security algorithm. That means updated algorithms, very good algorithms are there. Backward compatibility with traditional VPNs are also there. Okay. If you remember, in IKE version 1, we used to have main mode and aggressive mode. So there were 6 messages exchange. Now all these message exchange process is also being reduced in Flex VPN or in IKE v2. Okay. See, this is the comparison. Easy VPN, dynamic routing protocol, not support. Doesn't support. DM VPN, yes, it support. Dynamic routing protocol. Crypto map, no. Flex VPN, yes. Dynamic spoke to spoke. If you see Flex VPN, yes. Remote access, yes. Configuration push, yes. Peer to peer configuration, yes. Per peer quality of service, yes. So you see there are a lot of features that you are getting in Flex VPN. Flex VPN uses use cases. Why Flex VPN? See, site to site basic Flex VPN configuration, hub and spoke, everything. So if you consider, okay, now see, this is the working Flex VPN configuration blocks. IKE to proposal has to be there. Proposal is there. Policy is there. Keyring is there. Profile is there. IPsec transform set or IPsec profile. Okay, everything you can do. You can create a transform set. You can call it in IPsec profile. Sorry. So now you see how IKE v2 message exchange take place. IKE proposal and key exchange material, accepted IKE attributes and key exchange material. So two-way exchange take place. Okay. Authentication material, authentication, exchange of authentication. Create child security association. IKE proposal for additional or relayed IKE security association. Hello B, this is A. Now they are exchanging information. See, I was telling you about the main mode 6 exchanges. Here it is open-ended. First IPsec security exchange minimum 9. Here it is minimum 4 to 6 messages. Authentication for pub key, SIG, pub key, encryption, PSK. Okay. So in short, this is the summary that IKE v2 or Flex VPN, or you can say this is the summary of IKE v2 features. Okay. So I have set up a practical between R1 and R2. These are the two peers we have. My internet, this site A and site B. R1 is site A and R2 is site B. Now R1 is already configured. So when I say 12.1.1.2 ISP, I can ping 23.1. This is my site R2. Can my R2 ping R1? Yes. So both the connection is up. I have also created a LAN. Okay. So now first thing I will do is what? I will create a proposal. So what is my practical today? I am creating a site-to-site VPN between or flex VPN between R1 and R2 with VTI method. So this is my practical for today. So I am going to create crypto IKV2 proposal, and I named this proposal as ABC. When I name this proposal as ABC, he gives me a warning that you can't keep this empty. You have to feed it with something. Proposal must either have a set of an encryption algorithm other than AES, GCM, and integrity algorithm and a D. Okay. So he's asking me to configure the encryption algorithms. So I will configure AES CBC 256 for encryption. For integrity, I will go for hash algorithm SHA-512 group 5. Then I create a policy, crypto IKV2 policy, some number, proposal, the one which you created, ABC. Then I go and say crypto IKV2 keyring and some name. So I said hub. My peer is R2. My peer is what? R2. And the IP address of this peer is 23.1.1.1. And the pre-shared key is Cisco. Pre-shared key, I explained you in site-to-site VPN also. Pre-shared key is nothing but peer's identity. I want to check whether I'm building the tunnel with my right peer or not. That is R2. And for that, I have to do peer's identity. I have to find out. And this is our pre-shared key that we are going to use. Okay. Next, I create IKV2 profile, some name XYZ. Match identity, the remote address 23.1.1.1. I also use subnet mask. Authentication local pre-share. Authentication remote pre-share. Key ring local hub. Crypto IPsec profile default subname. Set IKV2 profile XYZ. I can also create a transform set and set it. Or I can use the default transform set. Interface tunnel 0. IP address 10.1.1.1. The private IP address I am going to use for the tunnel. No shut. Tunnel mode have to be changed because by default it is GRE mode. And then I apply tunnel source 12.1.1.1, tunnel destination 23.1.1.1, tunnel protection IPsec profile, the name of the profile that I create. So when I say show run, I can see proposal is being configured, policy is being configured, keying is being configured. I have to use the same configuration for R2 also. You cannot have a different policy and proposal. So I'll make a note. Edit it. 12 R1 12 tunnel source 23111 tunnel destination 12.1.1 tunnel IP address is 2. See, my configuration for R2. Definitely config T. This time, if I'm doing it on R2, my peer is R1. Let me paste this configuration on R2. So see, my tunnel is up between R1 and R2. I can ping also. I have my LAN with this PC. Okay. So IP route. Show crypto IQ to session is the command to check phase 1. So when you give this command, you can see the status is up, active. Child count 1, I count 1. Local IP address is 12.1.1.1. Port number 500, UDP port number 500. Protocol number is 50 and 51, you know, ESPNH. It is showing you the lifetime 86,400 seconds. So if my phase 1 is up, I can now go for phase 2. You can see this is my phase 2. Now what I'll do, I will try to send my traffic from PC. Let me just stop this. Start. So ping 192.168.10.1 my gateway. Pinging. Ping 172 16.10.1. This is my branch plan. Okay, so now it's not pinging. So what I'll do some routing. I say IP route to reach 172.16.1.0 255.2510.0. Sorry. Go to tunnel save. Here I will say config T IP route to reach 192.168.10.0 255.255.255.0. Go to tunnel 0. You can see I can ping my branch PC. So this is my branch PC with the IP address of 172.16.10.2/24. Save it. And this is my okay. What is my IP address? Twelve dot one dot one dot one. With my 12.1.1.2. This is my 23.1.1.2. Uh, 172.16.10.1. And this is 23.1.1.1. So my traffic is going inside the tunnel. You can see when I give the command, you can see 10 packets. Now again I send some ping packet 11, 12, 13, 14, 15. So you see now 15 packets getting encapsulated. If I send the traffic from here, VPNs are bidirectional. 16, 17, 18, 19, and 20. 20 packets get encapsulated. Show crypto IQ2 session is the command to see the phase 1. Show crypto IPsec SA is the command to see phase 2. If phase 1 is up, then definitely phase 2 will also come up. But if phase 1 comes and there is some issue with some configuration, then this phase 2 also cannot, it's not necessary that if phase 1 is up, sorry to say that, if phase 1 is up, that doesn't mean that phase 2 will come up. But if phase 1 is not up, then definitely phase 2 will not come up. Okay, I wanted to tell you that phase 1 is necessary. Okay, phase 1 is nothing but negotiation of policy, Diffie-Hellman exchange, and Pierce identity in I version 1. Now in I version 2, they made it more faster. Okay. Now what is troubleshooting in this? Okay. You can also add a transform set. You know, a transform set is nothing but I am just calling the algorithms which will be used for data encryption. If I'm doing that, it's okay. So what I can do, I go to tunnel 0 and say no tunnel protection IPsec profile default. Okay, and then I create crypto IPsec transform set some name preset ESP AES ESP SHA 512. Now I can call this transform set into profile. Which profile? The one I created. This one. Set transform set. Go to interface tunnel 0 and say tunnel protection IPsec profile default. Okay. Now same transform set I'll be using it here also. So first we'll remove this. No tunnel protection IPsec profile default. Create a transform set. Go to IPsec profile. And call the transform set. Go on interface and apply it. Tunnel protection IPsec profile default. Show crypto IQ2 session. Show crypto IPsec essay. 0 packets. We'll try to send it. You can see packet started encapsulating and decapsulating. So we can do transform set also. Now in case if you want to troubleshoot or some problem occurs. So what could be the problem? So possible that your pre-shared key is not correct. So if I go here and say my pre-shared key is here R2, my pre-shared key is say disco. And I say shut, then I say no. Okay, and then I debug crypto IQ2. Okay, show crypto IQ2 session. See, I lost the connection. S2 is not coming up. Debug crypto IQ2. See, process authentication response, authentication exchange failed. Sending packet. Use pre-shared key for ID, data generation, pass, authentication exchange failed. Why? Because I changed the key. So now what happens if I try to send the ping packet, it will not go. Show crypto IQ2 session. My phase 1 is not up. So if my phase 1 is not up, how my phase 1 will come up? So old one. See, you can't see packets getting encapsulated and decapsulated. It's not up. . Okay. Continuously flowing with message, zero encapsulation. Get peers authentication method, PS key, okay, preset key. Use preset key, I authentication data, my authentication. So there is some issue. He's pointing me out. We need to read these errors and we have to understand. So let's go and change the preset key because it is getting mismatched. And just because my preset key is getting mismatched, my phase one is not coming up. My phase one is not coming up. That means my phase two will also not come up. So I'll go here and say Cisco. Interface tunnel 0 shut. Say no shut. Okay. Now you can see my traffic is moving. So this was my Flex VPN. I did Flex VPN between R1 and R2. I showed you troubleshooting in case if my phase one is not up. In case if there is some problem with my preset key or algorithms. Okay. There is a chance because see, I'm using the same algorithms like, okay. So let's see, we'll change the algorithm. Go to proposal and instead of encryption algorithm AES CPC, I will use AES CPC 128. And integrity, I will use SHA-1. Shut, no shut. Show crypto IQ2 session. See? Show crypto IPsec essay. So what I did just now, I changed the algorithm. I made it AES CBC 128. There it is AES CBC 256. If you want to see it. Now my tunnel also must have gone down. See? Receive no proposal chosen notified. So now he will talk about proposal. We'll talk about proposal. There he was talking about preset key. See, I'm showing you troubleshooting. You have to understand the message, debug messages. Fail to find a matching policy proposal. In fact, he pointed out also AES CPC 128 and SHA-1. Clear? So now we'll correct it. Ball. Go and change the encryption integrity SHA 256. Go to interface tunnel 0 and say shut, no shut. So crypto IQ2 session. So it is AES CBC 256. Okay. So here it is 512. See again. Integrity is what? 512. See. Now I try to show crypto IQ2 session up. Now I try to change something in transform set. Is in okay. So I'll go crypto IPsec profile default, or I will create one more transform set. Crypto IPsec transform set pset. ESP, say I use suppose GCM. ESP no, I use ESP 3 days. Instead of SHA-5112, I will use 256 HP. So now you see, I change the transform set. I can't remove it, the one I have created, and I will go to IPsec profile default and say set transform set pset. So instead of T set, I show crypto IQ2 session. This is up. Show crypto IPsec SA. Now I try to send the packet. Now see, in Flex VPN, the dependency of transform set is less. Okay. So that is what happened if I change the transform set also from T set to P set. It is allowing the traffic to go. Let me just shut and see. So crypto IQ2 session 1. It is not working. Let me debug this. Debug crypto IQ2. So when I say show run, you can see show crypto IQ2 session. Again, it is gone. So what I'll do, I'll go to profile, set transform set. Zero shut and no shut. So again, I say IQ2 session. Show crypto, let's say, try to send the ping. Okay. So yes, transform set issue is also considered. It's not, if you are mentioning transform set, he will consider, otherwise he will take default transform set. So this was Flex VPN. I showed you how to configure Flex VPN. I showed you the topology. I showed you the IP addressing. I showed you how LAN to LAN communication take place between R1 and R2, that is head office and branch office. How the Flex VPN communication take place, how phase 1 take place, how phase 2 take place. Okay. So I hope you understood this. Thank you very much. Take care. Bye.